Alright, so trigonometry functions. You learn about trigonometry ratio, sine, cosine, tangent, cotangent, secant, cosecant. In this lecture, we're going to dive a little bit more into the properties, the graph of these four trigonometry functions: sine of theta, cosine of theta, tangent of theta, and cotangent of theta. For sine and cosine functions, widely used in a lot of area in mathematics, physics, or the sciences. Um, whatever I'm talking right now, the sound wave that I'm speak out is travel in terms of sine and cosine functions. If you go to the hospital, then you see the scanners go up and down. Those are sine and cosine functions. Okay, or whatever kind of signal that you receive from any other places, the microwave, you play guitar, the sound from the guitar, something like that. Everything can be described using sine and cosine function or the combinations of sine and cosine functions. So it's very important to learn about sine and cosine, understand the graph, the behavior of the function, and the properties related to these functions. Okay, so before we go into the graph and the details of sine and cosine functions, I want to give you some definitions. The first one is the periodic, a period, and the other one is periodic functions. So the period, by definition, is the distance required for the functions to complete one full cycle. So if you go back to the previous lecture note, you look at the unit circle, and you can see that starting at 0 degree, you have the point 1, 0. So cosine starting at cosine 0 is 1, sine 0 is 0. And now you go around the circle, you complete one full cycle, you go back to the original point, right, with the same locations, right, 1, 0, even though you are 360 degrees. You do another cycle, you go back to the same point, right? So that is, in this case, the period is 2 pi or 360 degrees, because it's require you to go the full circle or the full 360 degree or full 2 pi to go back to the original location. Now, periodic function. So a function is periodic if there exists a positive number. I call that P, such that f of theta plus P equal to f of theta for all theta in the domain. So go back to the unit circle that you see earlier. Again, you start at 0 degree. Cosine of 0 is equal to 1. You complete one full cycle or one full 360 degree. You go back at cosine of 360 degree equal to 0. So in that case, in that scenario, you say that cosine function is 2 pi period. Right? You with me? And you can classify the functions to be a periodic function. You with me? Because look at the formula here, the function cosine of 0 is equal to cosine of 0 plus 2 pi. You okay with that? All right. So cosine function, now because the definition is in this lecture, so we should know for sure, right? We get to that a little bit later, but we know for sure that cosine, sine, tangent, and cotangent are periodic functions. And they will have different periods. Right. So those two definitions done, we're gonna dive into the graph and properties of sine and cosine functions. All right. So I have the graph of sine and cosine function here. So the curve in blue is the sine function, and the one in red is the cosine function. How could I possibly recognize that? Okay. Not only you have the wave curve like this, but also the sine function is the path function. It's symmetrical with respect to the origin. Cosine function is an even function because the graph is symmetrical with respect to the y-axis. You okay with that? All right. So I want to annotate this one. So here, this is the function y equal to sine of theta. And this curve is y equal to cosine of theta. The horizontal axis in this case is the angle theta. And the vertical axis is the output or the y-back. Now go back to the unit circle. You remember again the point at 0 degree angle. And cosine of 0 is equal to 1. Right here, cosine of 0 is equal to 1. And sine of 0 is equal to 0. You okay with that? Okay. So that's a quick example right there. Now let's fill out the information. You have the graph in front of you. The property of sine and cosine functions are as follow. So when you look at the graph, the domain of these two functions are from negative infinity to positive infinity. Right, so it's just go on forever. So from negative infinity to positive infinity for both sine and cosine function. Now, what is the range of the function? When you look at the graph, can you tell me what is the range of the function? Negative 1 to 1 and include the endpoints. This is true for both sine and cosine. Now, without the graph, you could still be able to determine the range of sine and cosine function. When you look at the constant or the coefficient in front of sine and cosine. All right. So this is the sine function. What is the constant in front of sine function? 1. Right. Right. So that one is called the amplitude. We get to that later in the next page. It's called the amplitude. So the amplitude for sine and cosine is 1 in this case. 1 is in front of sine. 1 is also in front of cosine. So the highest point it's going to get to is positive 1. The lowest point it's going to get to is negative 1. Therefore, the range from negative 1 to 1. Now, if you have a different amplitude, you have a different constant, let's say positive 2 in this case, then the range should be from negative 2 to positive 2. If the amplitude, let's say 100, let's go crazy on that, then the range should be from negative 100 to positive 100. You okay with that? Okay. There are the scenarios, for example, if you have the negative constant in front of sine and cosine, what's going to happen? You take the absolute value. So you can have negative 2 in front of sine and cosine function. The amplitude is still positive 2. Highest point you get to is positive 2, the lowest point is. Again, we get to that later, but I just want to point out to you, not only when you look at the graph, you can reduce that in the range from negative 1 to 1, but when you look at the algebraic formulations, then you can tell that the amplitude or the range. Good. Periodicity. So for sine and cosine functions, It should be 2 pi period. So algebraically, this is what you can write. So sine of theta plus 2 pi equal to sine of theta, and cosine of theta plus 2 pi equal to cosine of theta. Now, when you look at the graph, let's say you're at the top of the cosine functions, and you're going to go down and then up again, and you go up to the same height. That is where you can get a full cycle. Where you make the measurement from this point to this point, you will see that is 2 pi. Okay, so that's why it's 2 pi period. Same thing if you, let's say, start at the bottom here on sine functions. You complete one cycle and get to here at this point. That is also 2 pi. The way to recognize periodic function is that, let's say you look at this curve, and from, because it's 2 pi periods, if you cut the curve from 0 to 2 pi and shift it to the left or to the right, right? So from 0 to 2 pi, you take this curve and you map it from 2 pi to 4 pi. The behavior of the function is going to be the same. Good. Again, if you cut this part from 0 to 2 pi and you translate that to the left, right, and then you have the curve start from negative 2 pi to 0, the curve behaves the same way as the curve between 0. Good. All right. Now, again, when you look at the graph, you can see that the sine function is symmetrical with respect to the origins, and the graph of cosine function is symmetrical with respect to the y-axis. So symmetrical with respect to the origin. Because of that, sine is an odd function, so this implies that sine of theta is an odd function. Now, algebraically, to identify an odd function, you write like this: sine of negative theta is equal to negative sine of theta. So symmetry for cosine functions is symmetrical with respect to the y-axis. So this implies that cosine of theta is an even function. And algebraically, you can describe an even function as cosine of negative theta is equal to positive cosine of theta. So these properties are very important to sine and cosine functions. So this property includes the domain, the range, the periodicity of functions, the symmetry of the graph of the function. Okay. So for the graph of the psi function, so the general formula for the graph of psi function is written in this form. Y equal to A times psi of dx. Okay, so let me explain a little bit here. So the graph of y equal to A times psi of bx for b is greater than 0 has, right? So you see in the formula there are two numbers, capital A and capital B. So capital A, so the amplitude is capital A is actually equal to absolute value of A. What that means. And the period is identified by the formula 2 pi divided by capital B. Okay. Now, when you go to the graph, you see the curve here. So the curve is the sine function curve. So y equal to A times psi of capital Bx. Now, the amplitude is measured from the horizontal axis or the x-axis to the lowest point or to the highest point of the functions. Right. So in this case, this part is the amplitude. You can also say that this part right here, you can use that part to calculate the amplitude. So they have the same length. Therefore, the amplitude is equal to 2 pi. Now, the period is 2 pi divided by capital B. So you start at the original point, not necessarily at the origins. So this is the starting point, and then you complete one cycle, you go back to starting point. And this is 2 pi period, 2 pi over B period. And you make the measurement from the original point to this point. This is called period. Okay, so let's work with one example here to kind of try to understand the theory of the sine function. Okay, so you are given this function y equal to 3 times sine of 2x, and you identify the amplitude and the period of this function. Alright, so the amplitude in this case, by definition, is the absolute value of the number in front of sine. So in this case, it's absolute value of 3. It's just equal to 3. So the amplitude is equal to 3. So when you have the amplitude, it say that the maximum the function can get to is positive 3. And the minimum that the function can get to is negative 3. Right. So the max value is y equal to positive 3, and the mean value is y equal to -3. Now for periods, you use the formula 2 pi over b. You have 2 pi divided by 2 is equal to pi. Alright, so you can conclude that each cycle is of length pi. Alright, good? Good. Now, using the information that we just got about sine function, we can do some transformations, specifically about the horizontal transformations. And you have this graph, right? New graph and the new formula. The new formula is y equal to a times sine of dx minus c. For c is any value. Okay. If c is equal to 0, then there's no transformation at all. That's one possibility, but if you want a horizontal transformation, then you want to give c a value that is different from 0. Okay, so the graph of y equal to a times sine of bx minus c for b is greater than 0 is obtained by horizontally shifting y equal to a sine bx so that the starting point of the cycle is shifted from x equal to 0 to x equal to b over c. You remember, so you see that now on this page you have two different graphs. So for the first graph, the starting point is at the origins, but for the second graph, the starting point is shifted to the right. And this shift allows us to have the starting point from x equal to 0 to a new starting point at x equal to b over c. So the explanation for this algebraic formulation is still the same to previous formula. That a is to the absolute value of a is to an amplitude. The period is calculated by 2 pi over b. The same thing. So the amplitude here, absolute value of a is equal to the amplitude but because you make a little shift, so this is the functions in the form of a times sine of bx minus c. And this is still 2 pi over b period. All right, so let me do some one little manipulations for my next explanations. So I have y equal to a times psi of bx minus c. Okay. So what I want to do is that I'm going to take b as a common factor compared to these two terms. And I'm going to get b times x minus c over b. You with me on this? Okay. So this clearly show the transformations, and the transformation or the horizontal transformation depends on the value of c over b, not just c. You okay with that? All right. So the b is there for the period. The transformation depends on c over b. You okay with that? Okay. I need that so that I'm gonna give some explanation, but bear with me here. So I'm gonna start with y equal to a times psi of bx minus c, and I take b as a common factor, and I get a times psi of b times x minus c over b. Now it depends on the value of c over b, then you have a different horizontal transformations. Okay. So if c over b is positive, then you shift right. If c over b is negative, you shift left. And there is a name for this fraction c over b is called a phase shift. Okay, so that's for psi functions and also the transformations related to psi function. We're going to do the same thing for cosine function and then transformation cosine function. And after that, we're going to focus on a little bit on tangent and tangent.
So we just cover the graph of side functions of the form a times psi of bx, and then also the graph of transformation of a side functions. Now we're going to move on to look at the graph of cosine functions. From the first page, we know that cosine function is an even function. That means the graph is symmetrical with respect to the y-axis. In addition to that, when you look at the cosine function, you can deduce the value of the amplitude and also the value of the period of the function. Alright, so similar to the sine function, there are two quantities that we want to calculate. The first one is again the amplitude, and the second one is the period. So the graph of y equal to a times cosine of bx for b is greater than 0 can do value that we want to calculate. The first one is the amplitude is equal to the absolute value of a, and the period, which is calculated by the formula 2 pi over b. Right. Now when you go to the graph, you can see that this graph right here is the graph of the cosine function. So this is y equal to a times cosine of bx. And again, this is the amplitude equal to the absolute value of a. Again, amplitude is measured from the x-axis to the highest point on the graph. Or you can measure the amplitude as the from the x-axis to the lowest point on the graph. So this is also the amplitude of the graph. Okay. And the period is the distance that required for the function to complete one full cycle. Okay, so in this case, the period is 2 pi over b, and again, this is the period. Okay. So now we're going to use this information to calculate some example. So in example 2, you are given the function y equal to negative 3 times cosine of pi over 2x. And we want to calculate the amplitude and also the period of the functions. So the amplitude by definition is equal to absolute value of a. So in this case, a is equal to -3, so you have absolute value of -3 or 3 for that matter. So this tells you that the maximum value of the function is +3 and the minimum value of the function is -3. So here the max value is y equal to 3 and the mean value is y equal to -3. Again, that means when you graph this function, the highest point that the function can get to is +3, and the lowest point the function can get to is -3. Okay, now next, the period. So the period is equal to 2 pi over b, given that b is equal to pi over 2 in this case. So 2 pi divided by pi over 2. So in this case, you divide a fraction, that means you can multiply by the reciprocal. So 2 pi times 2 over pi. So this is equal to 4. So pi cancel out, and 2 times 2 is 4. This tells you that each cycle is of length 4. So after 4 units, the graph of the function will repeat itself. Okay, so let me show you the graph on decimal. So this is the graph that I just plot using decimals. The functions that we get is y equal to -3 times cosine of pi over 2x. Now we look at the graph of the function. You can see that the highest point of the function is 3, and the lowest point of the graph of the function is -3. And the function is cosine function, so it's symmetrical with respect to the y-axis. If you zoom out, you can see that the function is symmetrical with respect to the y-axis, and cosine function is a periodic function, so the behavior of the function repeats itself over a certain interval. The length of the cycle is 4, so you go up here, and then you go back to the x-axis at 5. So the length or the cycle is, or the period is equal to 4. So now let me move on to the graph of a transformations of cosine functions. So in this case, again, we just want to consider the horizontal transformation. So the form of this transformation is y equal to a times cosine bx minus c. And depend on the value of c, we can have a different type of horizontal transformation. Either you want to transform this to the left, or you want to transform the function to the right. Okay. So the graph of y equal to a times cosine of bx minus c for b is greater than 0 is obtained by horizontally shifting the graph of y equal to a times cosine of bx, so that the starting point of the cycle is shifted from x equal to 0 to x equal to c over b. Right. If you compare this definition with definition in sine function, they are very similar to one another. It's just that we have a different type of function. One is sine function, the other one is cosine function. This type of shift or this type of transformations allow you to move the starting point from the origins to another location. In this case, that is x equal to c over b. Okay, so let's take a look at the graph here. So the graph of the function has the form of y equal to a times cosine of bx minus c. From this formula, you can deduce that the amplitude of the graph of the function is equal to absolute value of a. The period is calculated using the formula 2 pi over b. And the starting point now, instead of at the origins, is shifted to the point x equal to c over b. So this is the new starting point. Okay. So now let me do a quick manipulations to talk about the starting point c over b a little bit better. So given the original function a times cosine of bx minus c, I will take b as the common factor for the term inside the parentheses. Now I'm left with a times cosine of b times x minus c over b. So this manipulation allows me to see the transformation a little bit better, and the transformation affects the function horizontally. So you have the value c over b. If you want to shift the function to the right, c over b has to be positive number right here. And if you want to shift the graph of the function to the left, the value c over b has to be a negative number. And there is a name for this value c over b. It's called the phase shift. Okay. So far in the last two pages, we focus on the graph of sine function and cosine function and their transformation. So there's some values that you need to calculate. The first one is the amplitude, which is equal to the absolute value of a, the period of the function, which is 2 pi over b, and these depend on the function. You have a different starting point, either at the origin or at x equal to c over b. Okay, so using this information, we're gonna apply that to some example. So in example 3, I want to calculate the amplitude, the period, and the phase shift of the functions of the sine function of y equal to 4 times sine of 2x minus 2 pi over 3. Okay. So first, let's calculate the amplitude. So the amplitude is equal to absolute value of a. So in this case, absolute value of 4, or just 4. Right. I'm not going to write it down anymore, but I want to mention that the highest point of the graph of the function is positive 4, or the lowest value or the smallest value that the function can get to is negative 4. The period is calculated as 2 pi over b. So for b is equal to 2, so the period is equal to pi. That means that each cycle is of length pi. Okay. Now for the phase shift is equal to c over b. For c is equal to 2 pi over 3, and b is equal to 2. So 2 pi over 3 divided by 2. So you get 2 pi over 3 times 1/2. Now the 2 cancel out and you're left with just pi over 3. Okay. So this say that a cycle will start at x equal to pi over 3, or the starting point now gets shifted to the right by pi over 3 units. So a cycle starts at pi over 3. Okay. Let me show you the decimals graph of the function. So this is the graph of the function for y equal to 4 times sine of 2x minus 2 pi over 3. Okay, so again, the amplitude is equal to 4. So when you look at this graph, the highest point of the graph is positive 4, and the lowest point of the graph is negative 4. Each cycle is of length pi. So if you start at pi over 3, it will take a length pi to get to 4 pi over 3. Okay, that to complete one cycle. And the phase shift is pi over 3. That means that the function is shifted to the right by pi over 3 units. So a new cycle will start at pi over 3, take a pi period to complete one cycle. Now you start at a new cycle of 4 pi over 3, so on and so forth. Now let's move on to the next example. In the example 4, again, you want to calculate the amplitude, the period, and the phase shift of the function y equal to negative 2 times sine of 2 pi x plus 4 pi. In this case, the amplitude is equal to absolute value of a, or absolute value of negative 2. This is equal to positive 2. Again, the highest point the graph function can get to is 2. The lowest point that the graph function can get to is negative 2. The period is equal to 2 pi over b, for b is equal to 2 pi in this case. So 2 pi over 2 pi is equal to 1. So that means that each cycle is of length 1. Now for the phase shift, this is equal to c over b, for c is equal to negative 4 pi divided by b, which is 2 pi. You may wonder why it's negative 4, because if you go back to the definition of sine and cosine and the transformation, you see that the definition should be y equal to a times sine of bx minus c. And in this case, you have plus 4 pi. So technically, what we need to do is rewrite this function as negative 2 times sine of 2 pi x minus negative 4 pi. And therefore, the value of c in this case is negative 4 pi. So for you have negative 4 pi over 2 pi, this is equal to negative 2. And that means that a cycle start at x equal to negative 2. So basically, you shift the function to the left by 2 units. So now let's move on to example 5. So in this example, the function that we have is y equal to 1/2 times cosine of 4x plus pi. Now, if you compare this function with the definitions, you see that you need to manipulate the function a little bit in this case. You have 1/2 times cosine of 4x minus negative pi, so that you can find the value of a, b, and c a little bit better. So in this case, a is equal to 1/2, b is equal to 4, and c, be careful, is equal to negative pi. Okay, so the amplitude is equal to the absolute value of a, or absolute value of 1/2, or equal to 1/2. The period is equal to 2 pi over b, or this is 2 pi over 4. It's equal to pi over 2. That means each cycle is of length pi over 2. Right. And the phase shift is equal to c over b. In this case, c is equal to negative pi, and b is equal to 4. So a cycle starts at x equal to negative pi over 4. So in this case, the cosine function is shifted to the left by pi over 4 units. So the starting point is at negative pi over 4. So I hope that makes sense to you. When you say you shift it to the left by certain units, you just say the positive or the absolute value units, right, which is pi over 4. But the starting point is at the location x equal to negative pi over 4. Now for example 6 is going to be very similar to the last 3 examples. You look at the function and you compare with the original definitions, and you see that we need to manipulate the expression inside the parentheses again to get negative 4 times cosine of 2x minus negative pi over 2. Okay, so the amplitude is equal to absolute value of a, or in this case, a is equal to negative 4. So therefore, you have absolute value of negative 4, a positive 4. Again, I want to reiterate that the highest point that the graph function can get to is positive 4, and the lowest point is negative 4. Now for period, this is equal to 2 pi over b. Is equal to 2 pi over, for b in this case, 2, which is equal to pi. So that is each cycle is of length pi. Okay. And for the phase shift, is equal to C over B, for C is equal to negative pi over 2 divided by 2. So you do negative pi over 2 times 1/2, or you get negative pi over 4. So in this case, again, you have the cycle to start at x equal to negative pi over 4. So a cycle starts at x equal to negative pi over 4. And that's it for sine and cosine function and all the transformations. Again, in the graph of sine and cosine function, most of the time we want to calculate the amplitude, the period, and the phase shift of functions. We're done with sine and cosine, and now let's move on to tangent and cotangent function. So for tangent and cotangent functions, when you look at the graph, you can see that these have some weird behavior on the functions. The reason for that is if you look at the tangent of theta, or rewritten tangent of theta in terms of sine and cosine, you obtain fraction. So tangent of theta is equal to sine of theta over cosine of theta, and cotangent of theta is equal to cosine of theta over sine of theta. So when you have a fraction, you don't want 0 in the denominator. What you do for domain is that you want to solve for theta such that cosine of theta is different from 0. So now how could you solve for theta? How could you obtain the theta? So you want to look for the value of theta such that cosine of theta is different from 0. Now let me go back to the unit circle that we have in the last lecture. So when you look at the unit circle, you can see that if you can take in a lot of value of theta, except when theta is equal to 90-degree angle of pi over 2, or when you have theta is equal to 270 degree or 3 pi over 2. Now, if you make the observation further, you can see that not only we need to exclude the value of pi over 2 or 90 degree, or in 270 degree or 3 pi over 2, you can continue the cycle to 5 pi over 2, then 7 pi over 2, and then 9 pi over 2, so on and so forth, to forever, right? Because this function are periodic functions, and you just keep going forever if you like. Alright, not only that, you exclude the positive angle pi over 2, 3 pi over 2, 5 pi over 2, so on and so forth. You can go to the negative sign as well, right? So you want to also exclude negative pi over 2, or negative 3 pi over 2, and negative 5 pi over 2, so on and so forth. Again, we try to find the domain of tangent of theta. Again, cosine of theta is different from 0. That is, we're looking for theta such that cosine of theta is different from 0. By the look, when you look at the unit circle, you can deduce that, okay, theta has to be different from, let me start over here, pi over 2, 3 pi over 2, 5 pi over 2, so on and so forth. Again, not only you can go to the positive side, you can also go to the negative side of the real line. So you want to exclude negative pi over 2, negative 3 pi over 2, and negative 5 pi over 2. So the dot on both sides of this list indicate that we can go on forever to the negative side or to the positive side. Alright. Now, when you look at this list, you can see a certain pattern occur to help us rewrite the answer a little bit better. This is 5 for the answer, but I want to make it a little bit simpler. So that is, you exclude the value of theta at every odd number of pi over 2. Right. So here you exclude the value of 1 pi over 2, you exclude 3 pi over 2, you exclude 5 pi over 2. So 1, 3, 5 are odd numbers. Okay. So to make the formula for this exclusion, you do 2n plus 1 stand for odd number of pi over 2. What is the value of n? For n is an integer, so including negative integer, 0, and positive integer. Okay, so n can be dot 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 -2, -1, 0, 1, 2, 3, so on and so forth. So theta different from 2n plus 1 times pi over 2 is the domain of the tangent functions. Okay, now for the range of the function, when you look at the graph function, you can see that there's no restriction for the range of the function. So the range of the function is from -infinity to +infinity. And the periodicity of the function is pi period. So you can write that tangent of theta plus pi is equal to tangent of theta. And symmetry. So the function is symmetrical with respect to the origin. Indicate that the tangent is an odd function. And therefore, tangent of negative theta is equal to negative tangent of theta. Now, one more thing occur in only for tangent and cotangent function, that you have vertical asymptotes. Because you exclude a lot of values here in the domain, those are the vertical asymptote. So the vertical asymptote you have is theta equal to 2n plus 1 times pi over 2, where n is equal to dot 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 -2, -1, 0, 1, 2, so on and so forth. Okay. And when you look at the graph again, this is the graph y equal to tangent of theta. You can see that there's no restriction for the range, but for the domain, you have that we exclude the value pi over 2 here, and 3 pi over 2, 5 pi over 2, and if you continue with this periodic function, you will see we will exclude 7 pi over 2, 9 pi over 2, so on and so forth, and we can also go to the negative side of the real line. So here you have to exclude negative pi over 2, therefore there's a vertical asymptote at that point. You exclude pi over 2, therefore there is a vertical asymptote there. This is 3 pi over 2, this is 5 pi over 2. So cotangent function is written as cosine of theta over sine of theta. So this is also a fractions. And in finding the domain of the function, you need to exclude the denominator. So that is, so sine of theta is different from 0. Okay. So that means, again, you need to look for the value of theta such that sine of theta is different from 0. So let's go back to unit circle. So you see on the unit circle the value of theta such that sine of theta is equal to 0. So you see here theta is equal to 0, theta is equal to pi, theta is equal to 2 pi, so on and so forth, 3 pi, 4 pi, 5 pi, so on and so forth. Not only that, you can go to the positive side, you can also go to the negative side of the circle. When you start at 0, you exclude negative pi, you exclude negative 2 pi, negative 3 pi, so on and so forth. So therefore, the domain is theta is different from negative 3 pi, negative 2 pi, negative pi, 0 pi, 2 pi, 3 pi. Okay. So you have again to rewrite this list of numbers in a compact form. Right? So it's just the integer of pi, or theta is different from n pi, or n is equal to -3, -2, -1, 0, 1, 2, 3, so on and so forth. Okay. So I could just ask you to try to understand how to get to this value, right? So in the case of tangent of theta, and this value in the case of cotangent of theta. You don't have to write in the compact form. It's just that I want to give you the information. Okay. Now, when you look at the graph of when you look at the graph of cotangent of functions, you can also see that the range, there's no restriction on the range. So the range is also from negative infinity to positive infinity. And this is also pi period. And the cotangent can be written as cotangent of theta plus pi equal to cotangent of theta. And it is symmetrical with respect to the origin. Right. So this is an odd function. And cotangent of negative theta is equal to negative cotangent of theta. Okay. Because you exclude a lot of value of theta in the domain, those are going to be the vertical asymptote. So in this case, you have theta equal to n pi, going to be the vertical asymptote, where n is equal to -2, -1, 0, 1, 2, so on and so forth. Okay, so when you see here, this is the graph of cotangent of theta. Okay, and you exclude the value of x equal to, or theta equal to pi, theta equal to 2 pi, theta equal to 0. Any multiple of pi, right? For in this case, n times pi. Okay, so here is the function y equal to cotangent of theta. So that's it for me. Please let me know if you have any questions. Thank you.